So in this video, we're going to continue looking at solving system of equations, but this time we're going to look at how we would solve a system of equations by substitution. In our last lesson, we were looking at how we would solve them by graphing, which is fine, and that gives us a good visual and a good introduction to what we're doing. But the problem with graphing is that if the numbers get very large, those numbers are very difficult to fit on a graph. If the point of intersection was supposed to be 150 and 235, we would need a very large graph to be able to find that point of intersection and to draw those lines. You might say we could adjust the scales. The problem is if we adjust the scales, then trying to find that point of intersection accurately would be very difficult. If each grid space is 10 or 20 units wide, we'd probably have that point of intersection not intersecting at grid lines any longer, and now we would have an accuracy issue. So graphing is okay for a visual, but is really limited in what it can solve accurately. So what we want to look at is some algebraic methods that will get us to that same point. So before we get into the actual method, I have a couple warm-up questions I just want to work through with you. As it says, we're going to solve by substitution, so a couple substitution questions. So the first one, just a reminder, says that we're going to sub x equals 5 into this equation and solve for y. So remember, as a substitution, as we're doing this, okay, I'm just replacing the x with what it tells us to sub in. And when we do that substitution, we normally get rid of the x and we replace it with brackets. So there is our substitution line, and then very quickly 2 times 5, which is 10 minus 3, gives us our answer here of 7. Likewise, we can now extend that same idea to substitute that x is 3y plus 1. So it's the same idea, but instead of substituting a number in for x, we are now going to substitute in this algebraic expression in place of the x. And then it's going to say solve for, my correction here, solve for y. So if we do that, substitution, same thing, 2 in place of the x. I'm now not replacing with just a single number. I want to replace it with this whole expression, 3y plus 1. And then we continue with our equation, minus 5y equals 7. And notice that we've now created an equation where the x is gone, and I've created an equation that has just a y variable in it. So now we're able to solve for y. So if I do that, we end up here then with our equation solving skills. I need to expand our bracket. So I'm going to get 6y plus 2 minus 5y equals 7. Okay, before I start solving, I can actually simplify more on this side. So I'm going to say 6y minus 5y, that's y plus 2 equals 7. And then just a quick step here in the end. This is why we reviewed equation solvings earlier in our unit, because to get rid of adding 2, I'm going to subtract 2. So there's our answer. So these are the skills now that we're going to use to try and solve our system. So that's what this is saying. We can now use these skills to solve this algebraically instead of by graphing. So same idea I'm asking you to solve. Here's our 2 lines. Notice the second line is in the form y equals mx plus b. The first is not. But instead of graphing, we're now going to use these skills here. I start out the same way. I still number the equations. That's our first line, and that is our second line. But now I'm going to solve this purely algebraically. Notice the scenario that we have here looks a lot like what this was here. X equals this expression, so we were able to sub that into this equation. This time it's not x equals, but I do have this y by itself here, that y is equal to this stuff here. And that's what we're looking for in this method. When I have an isolated variable, I can always sub that equation into the other. So I'm going to say here on the side, here's our big step, sub the equation with, so sub the equation with the isolated variable into the other equation. And that's our big step when we're starting this question, is recognizing where do I have this isolated variable, and this time it's in equation 2. It could have been the other way around, that's fine. This could have been x that is isolated, similar to this that is up here. But wherever that isolated variable is, I'm going to take that equation and I'm going to substitute that now into the other equation. Now, as we solve system of equations, there is a little bit of formal work here that we do as well. You need to tell your reader what you are doing. So I'm going to actually write that out. I'm going to say I'm going to sub equation 2 into equation 1. This statement here is the same kind of statement that I made here. Here I gave it to you as a warm-up. Here you're going to have to figure out what are we subbing into what. I've also short formed this using our numbered equations instead of writing the expressions out in full, but it's basically the same idea here, other than you needed to figure out which one is being substituted into what. The idea works the same. So this is now saying I am going to replace y. Y is equal to this stuff here. So I am going to replace the y with this stuff right here. So we could put a little arrow and say there it is. In place of the y, I'm going to write this. So I start with this equation. If I'm going to substitute this into 1, and I'm going to say I have 2x plus 3. When I get to the y, I'm making my replacement. In place of the y, I am now putting in negative 2x plus 8. Y is equal to that, so we're replacing the y with that expression. And then we continue our equation that that's equal to 12. At this point, notice that I have an equation in terms of x, so I can go ahead now and solve this. I get 2x, okay, distributing the 3, I would get minus 6x plus 24 equals 12. Collecting my like terms, I have minus 4x plus 24 equals 12. And now I'm going to isolate my x. So I have negative 4x. I'm going to subtract off the 24, so that would give me negative 12. And then if I solve, I would get x equals 3. By doing that, we have solved for the x coordinate. We actually just found out the x coordinate for the point of intersection. So we actually have half of where these two lines are crossing. By substituting algebraically the one line into the other, we actually are able to solve for the x coordinate or the y coordinate for that point of intersection. Now that I have this, I'm now going to do a second substitution. I'm now going to say, okay, let's take that answer. I know these two lines will intersect when x is 3, and I can sub that back into either of these two lines to figure out what the y coordinate is. Remember, we're finding the point where these two lines are the same. So at this point, it doesn't matter if I put the 3 here or if I put the 3 here, I will get the exact same y value. Now, to make this easier for yourself, I would say wherever this variable is isolated, whichever one we were substituting in, okay, that is going to be the easier equation to work with. So I'm going to say sub x equals 3 into equation 2. So it's these two substitutions that we did in our warm-up. This is exactly what we're going to do to solve this system of equations. If I do that, I end up with y equals negative 2. I'm going to sub in that x value of 3 plus 8 gives us negative 6 plus 8, or there is my y coordinate. So that's our y coordinate of our POI. Put these two together. We'll say therefore the POI is, make sure you have them in the right order, x first and y second. And there's our point of intersection. Not always necessarily faster than graphing, but this will, if you can picture this now with larger numbers, this would work for very large numbers where graphing would be difficult to make this work. Also, if these were decimal answers or fraction answers, this would continue to work where trying to find decimal or fractions on a graph would be very, very difficult. So now we have a method that would work basically for all of our scenarios. I have a couple other examples here that I want to look at with you. So in our second example here, we have x minus 2y equals 2 and 5x minus 9y equals 12. Again, for good form, I'm going to say there are my two lines. I'm going to number them 1 and 2. I have a small problem in this question, and that's because if I look at what we said in our last question, I'm trying to find where I have an isolated variable. Okay, if I pull that last question back up for a second, okay, here it is. I was looking for where do I have that isolated variable. Here I have y equals. In this question, I do not have an isolated variable. Okay, so our first step is I actually need to isolate one of these four variables. I can either isolate the x here, the y here, the x here, or the y here. The easiest variable to isolate will always be the one that doesn't have a coefficient. Okay, so isolate the variable that doesn't have a coefficient. So what I'm going to do is this. I'm going to say, well, from this equation 1, so normally what I do is just a little arrow to the side. I'm going to say if I get that x by itself, to do that, to get rid of the subtracting 2y, again, we've done this in several videos now, I'm now going to add the 2y on the other side. So I'm going to say, okay, I have 2 plus 2y. This is the same line as this, it's just rearranged into a different form. Now, algebraically, when we do that, anytime I make a change to an equation, what we do is we renumber that line. So I'm going to say, well, that is now equation 3. Equation 1 and equation 3 are the exact same line, but they're written in two different ways. So for our reader, I'm going to tell them equation 1 is when I write the line this way, equation 3 is when I write the line this way. I'm just going to make note here that on the side of what we did, okay, I'm going to say isolate one of the variables. And in brackets here we'll say no coefficient is the easiest to isolate. So isolate one of your variables and no coefficient is the easiest one to isolate. We're now back to our two substitutions. So if I have now x isolated here, I am going to tell my reader I am taking that equation 3 and I'm going to sub that into the other line. Be really careful, it's not into either of the lines. I want to take this line, I'm taking this version of this line and I'm subbing it into the other line. Again, as we do that, this is saying we are replacing x with this stuff here. So I go to my other equation and I say I'm replacing x with that expression there. So if I do that, I have 5 in brackets 2 plus 2y as I replace the x with what it's equal to. And then I just continue with this equation. Okay, so there's our equation. Solving, I'm going to expand out the brackets. So 10 plus 10y minus 9y is 12. Collect my like terms. So 10 plus y is 12. This one ends up being really easy to solve. As I get rid of that 10, I have y is 2. Again, we're halfway there. I have half of the point of intersection. This time I actually found the y coordinate first. That's fine. I'm now going to do my second substitution. So I'm going to say, let's take that answer. So we'll say sub y equals 2 into, again, you can sub it into whichever line you want. For this line, we had two different versions, so I could sub it in here, here, or here. We should get the same answer in all three cases, since we are finding that common point, that point of intersection. The easiest one to work with, though, is usually this one here, wherever that variable is isolated. So I'm going to say, I'm going to sub this into equation 3. So if I do that, I have x is equal to 2 plus 2 times 2, which gives me an answer of 6. Therefore, the point of intersection is, again, we got to be careful with order, x first and y second. So there's our point of intersection. One last example, just a couple things to show. One, we don't always have x and y's. That's fine. We can have whatever letters we want. This still works. Okay, as I'm trying to isolate, we said isolate one of the variables. Okay, if there are none that are isolated, then we need to figure out which will be the easiest one. We said try to isolate one that doesn't have a coefficient. Okay, in this case, this is my only one that doesn't have a coefficient, although we're going to have to be careful because it does have that negative sign. You also see that the second equation is written in a slightly different form. That's fine. We'll still be able to solve this. The equation solving is just going to look a little different, but it's the same process. I start by numbering my two equations, 1 and 2. If I need to isolate a variable, I just put a little arrow to the side and I start isolating. I need to get rid of the 3a. That means I would be left with negative b, so we do need to be careful. Negative b, and I would have then 4 minus 3a. My b is not isolated yet. I still do need to get rid of that negative. We saw this in our last video as well, so I'm going to go through and divide everything by -1. So if I do that, I now have b equals -4 plus 3a. Careful as you divide by that -1, that this becomes -4, -3 divided by -1 becomes +3. I now have my variable isolated, so I'm going to renumber this and say there, that's equation 3. So equation 1 and equation 3 are representing the same line, just in a different form. Wherever I have my variable isolated, so there it is, okay, that's the equation I am subbing in. So I'm going to say, let's sub equation 3 into equation 2. In place of the b, then I'm writing this stuff here. So again, I can show you that I'm going to take that and I'm just going to put that in place of the b in the other line. So I start writing this second equation. I have 2a plus 2. In place of the b, I'm going to put -4 plus 3a. Now I still have that -16 equals 0. Expanding out my brackets, I have 2a minus 8 plus 6a minus 16 equals 0. Collecting my like terms, I have 8a minus 24 equals 0. I'm going to move the constant to the other side, so I'm going to add 24. That's going to give me 8a equals 24 plus 0 is 24. And I'm going to divide out the 8 so that a is 3. Once I have half of my answer, I do my second substitution. I'm now going to take that answer. So I'm going to say, let's take a is 3, and I'm going to sub it in where the other variable is isolated. So sub a equals 3 into equation 3. That will give me b is -4 plus 3 times 3. -4 plus 9 is 5. Therefore, POI is, so the question here, what goes first? Normally with x and y, we know the order from when we graph, x coordinate first, y coordinate second. If we have other letters, all we do is put them in alphabetical order. So A first, B second in their alphabetical order. That way, if we had any letters, Q, R, S, T, L, M, doesn't matter what letters we use in our equation, whatever two letters you're using, you just put them in alphabetical order here. That's it for today. Try the practice questions. Again, if you have any difficulties, send me an email and we can work through that together. Have a good day, everyone.